All right, let's look at Sapling Homework 5, questions 1 through 4. I talked about question 5 in the video, the lecture video for section 17.8. Question 5 is pretty tricky, so make sure you take a look at the video for 17.8. Question number 1 is asking you to draw the product of the reaction between a carboxylic acid and an ester, and this is the stuff that or a carboxylic acid and an alcohol. And this is the stuff that we did in 17.8. So you shouldn't have any trouble drawing the product of this reaction. And it does say just the product, singular. So it does not, oh wait, there's something I can see. There's something over to the right-hand side. This is not easy to use Sapling on a tablet, which you probably know that. Oh, over here on the right-hand side, there's that little tiny plus on the very right-hand side of the screen, and I can't scroll over, which I'm not totally sure why, but it says plus H2O over on the right-hand side. So it only wants you to draw the ester, and then it has plus H2O. The tricky part of this problem is going to be that you have to come up with the name of this molecule. It says write the IUPAC name, so that means the fancy formal name for this molecule. And this is actually going to be tricky for you because you do not know the name of this carboxylic acid. Remember, when you are naming an ester, you name it as if it were a carboxylic acid. So you have to know the name of the carboxylic acid in order to come up with the ester's name. This carboxylic acid is called benzoic acid. So when you are converting its name down here to become an ester, it is going to be benzoate. And there's going to be something in the beginning of the name as well. Remember, you are going to have to name the carbon chain that is attached to the ester. So you'll fill something in here, and you'll draw a really cool structure up here of the carboxylic acid, and then you will give this guy a name. And I believe in you. I know you can do it. For question number 2, this is from section 17.9. So the first thing that it wants you to do is draw the product of hydrolysis. So you have an ester, and it wants you to draw both products. There's going to be 2 products. You're going to draw carboxylic acid, and you're going to draw an alcohol. You shouldn't have any trouble with that. And then the second part of the question, this is saponification. So down here, it wants you to draw, again, 2 products, just like we did in the notes. This one, remember with saponification, there's a lot of options. It could be plus LiOH, it could be plus NaOH, it could be plus KOH, or it could be plus 1 equivalent of OH minus. So what I want to do here is show you how you're going to draw this guy, because it is going to have a charge on it, and I don't think that we've done anything with charges yet. So what I'm going to do, I'm not going to draw the whole thing out for you, but I'm going to draw the carboxylic acid part. It's going to look like this. And if this was a regular carboxylic acid, we would have this H on it, but it's not. And if we knew, like if it was LiOH or KOH or NaOH or something, there would be more elements, not just carbon, oxygen, and hydrogen. You'd have other buttons out here to choose from, so you could add the Li or the Na or the K. We do have to put a charge on this oxygen, and the charges are in the more option, and then there's the plus or the minus charges. So our oxygen needs to have a negative charge, so we'll select the negative charge, and then you just click on the oxygen to put that negative charge there. And yeah, it's sitting right on top of the oxygen, but that's okay. Sapling doesn't care. And then you're going to draw the other product of this reaction, which is an alcohol, and just follow along with your notes and you can do it. For question number 3, this one has some more hydrolysis stuff. So this is reaction A, that's hydrolysis. That's the beginning of 17.9. There's another one, 17.9, 17.9, 17. So these are all from 17.9. And you should have no problem drawing these. So you'll have two products, a carboxylic acid and an alcohol for all of these. The tricky part of this problem is going to be these last two reactions, reaction C and reaction D, because they have drawn the ester in a totally condensed notation. And the totally condensed notation is kind of awkward to look at when you're looking at an ester, because look at this weird OC double bond O situation that's going on here. So what I want to do is draw these condensed structures out with a little bit more detail to make it easier for you to solve this problem. So what I've done is I've just started right here at the carbon-oxygen double bond. I've got that drawn. And then I did the CH2CH3 right there. And now I'm going to go to the left. So now I've got this oxygen, and then there's a CH2CH, CH2CH, I'm just writing it backwards, and then a CH3, CH3. So there's a little bit more detail. So that should make it easier for you to draw that one out. And then for the second one, I'm going to do the same thing. I'm going to start at the carbon-oxygen double bond. I started at the carbon-oxygen double bond. And this time I'm going to go to the left because the left side looks pretty easy. O, and then a CH3. And now I'm going to go ahead and go to the right. CH2, CH, CH3. That's this guy right here. And then another CH2, CH3. So that should help you with that one. And then question number 4. Here's some more condensed notation. And we have lithium hydroxide, lithium hydroxide, lithium hydroxide again, but with line notation that's easier to look at. So let's start with this one right here so that I can show you how you're going to put the lithium and the charges and whatever in there. So maybe when you're drawing these, perhaps it might be easy for you to just draw that ester. Did you know that there's a shortcut for drawing rings? Like, boom, draw the whole ring at once. So maybe you just draw the whole ester like that, and then you erase, you just take a bond away. Erase the bond like that, and that's where the ester gets separated. The carbon-oxygen double bond, single bond, that is the part that is going to get the negative oxygen on it. And there's going to be a lithium there. Oh, I wasn't expecting that to happen. Maybe I have to make a bond to the lithium. We'll try that. And the lithium's got a positive charge. And then for my ring, I've got to put an OH on there. Like that. Now, I don't know if it wants that oxygen-lithium bond, so we'll see. I'm going to hit check answer pretty soon, and we'll see how it likes it. Actually, I'll just do it right now, even though I haven't done anything in the other 3 boxes. And we'll see how it likes it. It does not like that bond, so let's try that again. And let me see if I can erase. Oh, I did not want to erase that much. So let me see if I can just stick the lithium. Oh, yeah, I think it's going to like that. I'm just sticking the lithium somewhere near the oxygen. We'll see how that works. So it did like that. The question is still wrong because I haven't done anything for the other reactions, but notice that this reaction C, it doesn't have the red outline around it. So this is what it wants. Don't make an oxygen-lithium bond. Just stick the lithium somewhere and call it good. So let's go back up to these 2 with the condensed notation again. Tricky condensed notation. And let me draw those out for you so that you can do these ones. So again, I'm going to start with the carbon-oxygen double bond because I feel like that's an easy place to start. And I'm going to go to the right. So CH and then 2 CH3s, CH, CH3, CH3, and now I'm going to go to the left. There's an oxygen. Ooh, this is a beauty. CH with a CH3, so a CH with a CH3, CH2, CH3. So there's that one. And then let's look at this last one down here. So I'm going to start with the carbon-oxygen double bond. I'm going to go to the left. There's a CH2, CH2, CH3. CH2, CH2, CH3, and now I'm going to go to the right. O, CH2, CH2, CH3. So there are the structures of those esters, and that should help you get through these first 5 problems.